Hello. I was about to say good afternoon, but it's still morning, right? Good morning. Hopefully your morning's been good. I've seen a couple of really great talks actually so far, so looking forward to having a chat with you about developer happiness. So today's session is all about you, how to make you happy, but more importantly, how to make your company care that you are happy, and why it should matter to them, and how you can convince them to make your lives easier, and things that you can do inside your organization to make your life easier as well. So, first question, who here is a dev or would consider themselves a developer? Okay, that's most people. Who would say they're developer adjacent? Yeah, okay, cool. Are you happy, the devs? No, there's one no and just some laughter. That's great. That's probably a bit too deep a question. Instead of saying, are you happy just in general, can you think about the last day that you were doing real work? No offense to everyone, but this is not real work. I know because I do it for a living. The last time you did real work, like you sat down and you wrote some code and you implemented a feature, you did the thing that you're actually paid to do. Can you think about the last time and whether you felt good at the end of that day? Like, did you feel like you got stuff done? It was a productive day. Put your hand up if you thought, yes, that's a pretty productive day. I had a good day. Okay, that's probably about 20% of the room, so not great. What about in the last week? Who feels like they had a good, productive day sometime in the last week of their normal jobs? Okay, that seems like less, which is mathematically impossible, but we're just going to take that. So this is a common thread, right? You go to work, you do the work, you implement the features and so on, but you walk away just not feeling like it was that productive, like you didn't get things done. If you think about the last time you did have a really productive day, because I've had them, where you sit down, you do the work, and then at the end of the day, you're like, wow, I got some great stuff done. I feel good about what I did. This is what ideally you want as a developer or anybody to get to. Like every day you want to walk away saying, I did good work, I feel good about myself. We implemented the things we were supposed to implement, and we did a great job. So your happiness is important to you, and we want to explore a little bit about how you can get to that and what things prevent that. But we're also going to talk about why your happiness should be important to your organization, to your company. So traditionally, organizations, I guess you could argue, don't really care if you're happy as long as you're doing your job, right? If you walk away thinking, oh, that was a terrible day, but you got stuff done and you come back the next day and do it again, they're fine, right? Because traditionally the way that you measure productivity, and this is what the organizations care about, typically the way you measure productivity is a really simple equation, right? You look at the cost of the inputs, so we're all inputs, the cost of the human resources and all the other resources, and then the amount of money they make from the outputs, and if the output bit is bigger than the input bit, then great, success. And if you can skew that in one way, then that affects how well you do. But that doesn't account for how we feel as developers or how we feel as employees. That really only accounts for inputs and outputs. It's dehumanized, and so happiness doesn't really enter that equation. So what that usually boils down to in organizations is measurements like lines of code, how many commits you've made during a day, because those are raw productivity measurements, right? They don't measure how happy the developer is or even the quality of those commits and those pieces of code. They measure just this raw line that we're seeing on the screen. Are we making more money from the money that we are paying you? Right? So if this, I'm going out on a limb here, probably not so much, but this way of measuring how successful you are and how beneficial people in your organizations are is, what's the word? Terrible. Like it's really not a good measure. So if this is a bad measure of how well we're doing, what's a better way of measuring it? So who has heard of the SPACE framework before? Yep. Platform engineer in the room, of course. So this comes out of Microsoft research, courtesy of Nicole Forsgren and others, who's incredible researcher. She'll come up about 3 more times in this talk. I'm not going to go into too much detail. It's quite easy to find the details on this, but the idea behind the SPACE framework is it's a way to measure productivity in a holistic way. So it accounts for everything that affects productivity in an organization or in a particular sphere, right? It doesn't give you, you get 12 productivity points and that equates to this much profit, but it gives you a great way of kind of comparing how your productivity is going up or down depending on a whole bunch of different qualitative and quantitative measures. So if you're trying to measure and track the productivity in your organization or your team, this is a fantastic framework to use. The way you can do it practically is you take measurements across several of these categories and then you track them over time. And we'll talk about, we did this inside GitHub. Sorry, I work for GitHub. We did this inside GitHub a while ago and came out with some really interesting stuff about how we work internally and how we're productive internally. So let's look at the first one because it's more closely attached to developer happiness, as you'd imagine, satisfaction and well-being, right? So satisfaction is about how fulfilled you feel with your work, with your tools, the team, the culture, how that works as well. And well-being is about how healthy and happy you are, and how your work affects that health and happiness. And the question is, why should they care if you're happy and healthy, which we've mentioned. And it's a simple answer that satisfaction and well-being are important predictors of productivity. There's a lot of research, I'm going to go into the research in a sec, but for the moment, just trust me on this, that there's a lot more to productivity, but there's a lot of research that shows that happier employees lead to better productivity and even directly correlates to higher revenue. I'll point to some of the research behind that soon. That's a great one for just like printing out the research and dropping it on your manager's desk. So right now, I'll justify that soon, but right now, just trust me. I want to look at a different aspect, and then we'll talk about how to actually implement these measures. Efficiency and flow. So this is about how easily you're able to do your job, like practically how easily can you do your job. Is anyone familiar with Gene Kim? He was the author of the Phoenix Project and then the Unicorn Project, which was the subsequent book. They're books on DevOps essentially, but about development process and how organizations do that work. They're actually a couple of the few examples of books that are really great to read that talk about work-based stuff because they're set as novels. So you basically read it and it's just a story with a through line of this is the stuff that was going wrong in this organization. If you've ever worked for a very large organization, they can be a little bit triggering because they describe scenarios that are extremely real about meetings with 30 people that come out to nothing and that kind of stuff. But they're really good for introducing these concepts of this is how you get work done very effectively. One of the things that came out of the Unicorn Project, which was the second book, was about efficiency and flow. So you can think about it as if you are asked to implement a particular feature, how well can you do that without having to stop and look stuff up or stop and go and speak to the DBA team to spin up a new database for you? Or how much can you get into this flow state of being able to just implement the feature? How efficiently can you do that? And how much can you focus on that task? And again, there's going to be a lot of research that backs up how effective that is in increasing productivity, as well as just how much happier that makes you. I know as a developer, and I'm sure a lot of you in the room are the same, if you get an uninterrupted span of like an hour or 2 hours and can really dive into a problem, it just feels good, right? You come out of that and you've implemented all this stuff and you're like, where did the time go? It's an enjoyable thing. Like for a lot of us, that's why we do this, because we enjoy just sitting there and writing code and not having to spend an hour looking up why something's not working or looking up the implementation details for this particular code base. So efficiency and flow are about reducing things like context switching or waiting on other people. You might have heard of like the bus factor, which was what happens if somebody in your team gets hit by a bus, if they contained all of the knowledge. Gene Kim in the Unicorn Project introduces the opposite of that, which I think it was the coffee factor or something similar. If anybody's read the book, please correct me. But it's how many people do you need to sit down and have coffee with to get your job done? Because you sometimes have to go up the chain, across a bit, and then down to actually get the right person to do the work. And they're not in your team. You have to go and have coffees with people. So, this measure of how well you can do your work in an isolated, independent way is all about efficiency and flow. And so obviously it follows that efficient systems lead to more efficient outcomes. But just to put that in real terms, how much efficiency can affect the productivity of an organization, I'm going to switch to a way of explaining things for people's managers, which is really handy, which is dollars, right? So imagine you improve the efficiency of your process in your organization somehow, such that for your 100 developers, hypothetically, in your organization, every hour they save 5 minutes just because they don't have to do this thing anymore, right? Can anybody have a guess at approximate average developer salary, how much money that saves an organization, purely on salary costs, right? We're not talking about, people don't table flip and leave anymore and, all that kind of stuff. Can anybody hazard a guess? I mean, you could probably work it out roughly. For the year, across the year, yeah.
10 grand.
10 grand? It's about this for 100 developers.
Developers are bad at estimating.
That's great. That was, that's a great estimate. So it's like close to $1 million a year. That's purely salary cost, right? And you may have heard the rough metric of if a developer cost you $100,000 a year, that actually costs the organization $200,000 because of the overheads and the cost of the software and the equipment and all that kind of stuff. So it's more than that. That's a lot of money. That's purely just, if you can save me 5 minutes an hour, which is not a lot, by removing some of these obstacles, then that's real money savings, right? So think about that next time you go to your boss and just say, hey, can we pay for this? It used to be ReSharper. Now can we pay for Copilot? Or can we pay for this particular tool? Or can we migrate from, I'm not going to name the names. Can we migrate from this support issue ticketing system to this one because it's faster and it's more in my wheelhouse? So this is all productivity. And we've touched on the fact that you can improve productivity by making people happier. But I want to go a little bit deeper before we talk about how to make people happier and talk about what that actually means, making people happier. So I mentioned I work at GitHub. Has anybody heard of? Sorry, that's a rude question. So we actually have a really big advantage that almost no other company has, where we are our own customers. So we use GitHub internally for absolutely everything. This event right now, NDC Melbourne, is tracked as a GitHub issue in an IRL repository, which like in real life repository. And we have all of the details of that. There's automation, so when I filled out the issue form, it automated when it was and where it was and who it assigned it to. And I can, after this event, I just use some shortcuts and it will give me a form to fill out for a trip report and all that kind of stuff. So we use it for that. Our legal teams use it for tracking all their work. We obviously use it for our own code base, but we use it for absolutely everything. That gives us a massive advantage in that if we can do something to improve our own productivity using that platform, then that can be released to other people who pay us money because it helps their productivity, right? And there's a couple of examples of that. Copilot was a research project. Codespaces was an internal thing that we just started doing and then sold it. The canonical example of this kind of thing is Amazon or AWS working out how actually we've built all these systems to make what was pre-cloud, to make spinning up environments and virtual machines and things like that really efficient. Hang on, other people would benefit from this. Maybe they'll pay us a little bit of money and then suddenly they're one of the most valuable companies on the planet, because they improved their own efficiency, so they did that. So we have this massive advantage and a unique position that if we can improve our own lives as an organization, we can improve other people's lives. And so internally, one of the core things we talk about is developer experience, or DevX, because we can't say all of the words in tech. So developer experience, or DevX, I want to talk about that for a sec, because this is really kind of the heart of what makes us happy as developers, especially in an organization. So ultimately, it describes how developers work, so the systems, the processes, but also how they think and feel about the value their work provides. And this goes back to that original question of, did you feel like you had a productive day? You know, how do you think and feel about the value you're providing and the work that you're doing? So you don't want to just write code and ship code. You want to write code and ship code in an environment that's optimized for writing and shipping code. You don't want to, at the start of implementing some idea, realize that you have to fill out a 12-page change request form and then speak to the heads of 6 departments to get sign-off before you start doing the work. You want to just do the job, like do the work, right? Pick up the ticket or the issue and then just do it and finish. That's an optimized environment. This aligns with the space framework, by the way, that I mentioned, but it also aligns with another piece of research that we did internally a little while ago called the Good Day Project. So this was a project led by a research team inside GitHub, or GitHub Next, which is kind of our R&D department, led by Irini Kaliambako. And so she's one of the core researchers in GitHub Next. This was back in 2021, but it's still incredibly relevant. We basically mapped self-reports of whether somebody had a good day. So basically, I can't remember the details, but something like on a scale of 1 to 5, how good was your day at work? And we mapped that back to GitHub activity. So comments on issues, pull requests, commits, failed builds, all that kind of stuff as well. And we tried to align those two things. There were a few other measures as well. So we looked at things like meetings that people had, how many they had and when they had them and things like that. But the goal was ultimately to figure out what made the developers, at least inside GitHub, what made them feel productive, where those correlations were. The findings were interesting. I imagine as developers, they're things that some of them are a bit common sense and some of them are like, oh, I thought that might be the case, but I had no idea how relevant it would be. So one key finding, which I'm sure doesn't surprise many of you, is that to be effective and to have a good day, developers need deep focused time. So they need blocks of time to do the work that they're doing, both to be productive, but also to feel productive. So that leads to more commits, more pull requests and things like that, but a better feeling about those commits and pull requests as well. The likelihood that a developer will make progress towards whatever goals they have that day depends a massive amount on how much focus time they can get. And so you can quantify this, and this is in the report, you can quantify this when you think about meetings, which I mentioned. So in the study, can anybody guess, so if you have 1 meeting a day, where's my slide at? If you have 1 meeting a day, we're looking at the chance of developers feeling like they made progress towards their goal. Like you ask them at the end of the day, did you make progress towards the thing that you wanted to do today? And 1 meeting, or up to 1 meeting, 0 or 1 meeting, 99% of the time they're like, yeah, I did. Can anyone guess how much that goes down if we do 2 meetings? 30%. Down 30%, 50%? 30 is pretty close. 74. 2 meetings a day, it goes down dramatically, but you're still, most of the time you're making progress. Anyone want to hazard a guess at 3 meetings in a day? 40%? 0. 14% of the time. Yeah, pretty close. So if you look at your calendar, so this is in that research, you can have a look. And admittedly, caveat here, this is inside GitHub we did this. There's a lot of engineers inside GitHub though, and we are not a massive email culture where instant messages and GitHub issues and things like that. But so there are some people who have lots of meetings, some people who have very few. If you're lucky like me and the rest of your team is in a different country, then you either have meetings at stupid o'clock in the morning or at stupid o'clock at night, and then your middle of the day is fine. You can actually do work, which is great. But there's a lot of variation. This is what we found across the company though. So if you have 3 meetings in a day, the chances of making any progress are 14%.
Do you know what's considered a meeting? Like 5 minutes, something, or an hour?
That's great. Great question. Do I know what's considered a meeting? Nope. That'll probably be in that full report. I'll give you a URL to that if you want to read it as well. But my guess would be, at least kind of a half hour. You have a thing on your calendar. Yeah. All right. The antithesis of focus time, obviously, is interruptions. So meetings, you can kind of consider them interruptions if you want. And so we've all heard that if you break out of your flow, it takes a long time to get into. I don't know what the most recent number that everyone's quoting, but the idea was, if somebody interrupts you, it takes you 20 minutes to get back into what you were thinking. Because in general, as developers, we're holding a whole lot of things in our head. And if you get interrupted, we're like goldfish and it just kind of disappears. And you're like, okay, I was editing this file, but I forgot where that function call was and what it did and all that kind of stuff. It takes a while to get back in. So we were able to quantify this, how many interruptions and what that effect is. So we just did it really vaguely because it's quite qualitative, not quantitative. Difficult to determine like how many minutes you were interrupted for and how many times and things. It's not something we tend to track. But if you have minimal or no interruptions during your day as a developer, the chances of having a good day, so this was the measure at the end of the day, did you have a good day today, is about 82%. Anyone want to guess if you have, if you feel like the majority of your day you're being interrupted? And this is lots of feelings, right? Did you have a good day? Anyone want to hazard a guess? These are very qualitative numbers, I guess, in this case. 18? Yeah, pretty close, about 7% of the time. And this resonates with me especially. Like if you're constantly being interrupted during the day, like you get to the end of the day and you're like, well, I did nothing. And those interruptions admittedly can be people, but they can also be interruptions with an email or a message that you get from somewhere, or a failed build for this thing that you did a little while ago because the builds take half an hour and you've moved on and now you have an interruption from something else, right? So at the surface level, imagine if that build only took 3 minutes. Now that's not an interruption anymore. You can kick it off and then refill your coffee or whatever you want to do, and then you get that feedback straight away. And we'll talk about feedback loops in a sec. So interruptions, antithesis, it means that you don't have a good day. If you don't have a good day, you don't feel great. You're more likely to table flip and leave, or think this is not worth putting in all the effort because I do that and nothing comes of it. So again, happiness leads to productivity. This wasn't the only study we did around this either. In January 2024, we did another study released by a team. It included Irini again, but also Nicole Forsgren, who I said was going to keep coming up, from Microsoft Research. And it was fascinating. I admit I spent a long time going down this rabbit hole, so I apologize if I start ranting about things. But they basically looked at software development through the lens of work design theory. Has anybody heard of that? Okay. Work design theory, essentially, it looks at the work that, it's not specific to developers, but in this case, it looks at the work that developers do and how that work affects the outcomes, not just individual outcomes, but team outcomes and organizational outcomes. So the work that you do, how does that affect, the outcomes that you get out the other side, right? And they looked at 3 of the most important dimensions in the study that affect developer productivity. So we've mentioned a couple of them. Flow state, they're really important, like getting into a flow. Feedback loops, so do you get feedback on the thing that you've done quickly and effectively? And cognitive load, and that one requires a bit more explanation, so we'll come to that. Flow state we kind of talked about. As developers, you're generally pretty familiar with it. It's basically the ability to deeply focus on something without interruptions, so to get in a zone. So the study found that flow state, enabling a flow state, like clearing people's schedules so that they can get in this flow state, has positive impacts not just for individual outcomes, but also for team outcomes and organizational outcomes. So if you let developers get into a flow state, your company makes more money, is the whole big through line. So that's useful if you want to decline meetings. Say, I'm sorry, I care about revenue. Decline. Feedback loops are about outputs from one part of the system, being used as inputs to another part of the system. This is a very broad kind of definition, right? So for example, an automated test that fails is input for new work to fix a bug, right? If you've ever heard me speak at other NDC events or other things, you probably heard me bang on at length about DevOps. In DevOps and software process in general, we care a lot about the speed of feedback loops. So can you quickly get information about what work you've done in order to fix the loop before you, or fix the issue before before it goes too far and you have to spin up your brain again to work out what you were doing. But we also care a lot about the quality of the information. Has anybody got like a bug detecting or like observability platform or logging tool or something like that just floods you with stuff constantly, right? That is worse than not getting any information at all because you ignore it. You get 300 a minute and like none of it's important anymore. You can't tell, there's too much noise to the signal, right? Same thing goes for warnings in your IDE. Just turn warnings off, that's fine. Don't worry about it. Or fix them, I guess. You can do that, I suppose. Yeah, but if all you're getting is this gigantic block of things that you don't need to fix, no errors, but 7,426 warnings, you're not going to do that. There was a recent feature that we released with GitHub. This is kind of a tangent, but it's very related. GitHub Advanced Security, so it detects security vulnerabilities in your code base. We recently released a tool called Campaigns in that, because we were finding people would have their code base and that tool would say, you've got 14,000 software vulnerabilities, you need to fix them all. And that's insurmountable. Like, that's just noise. You're like, well, which ones are important, which ones aren't? Sure, you can sort by severity and stuff like that, but it's too much. So Campaigns was an idea of, well, let's narrow it down to this type of severity, this type of issue, this set of repositories. So now it's a meaningful thing that you can attack and try and get it done by a particular day. And that's all about reducing the noise and focusing on signal. So the quality of the information you're getting in your feedback loop. The idea is to get that in a timely manner, and that improves things as well. We'll talk about the findings of this in a sec. The last one, though, is cognitive load, which I'll admit I meant to put a slide on this when I built this talk and spend 5 minutes on it. And about 12 hours later, I was still reading about cognitive load theory, and I want to do a talk just on that, so I'm going to try and avoid doing that. But work design theory identifies 3 different types of cognitive load. There is intrinsic load, and so cognitive load you can think about as how much work you have to do in your head or, peripherally to do some work, right? Intrinsic load is the work intrinsic to that task. So I need to write a function to do this. Typing the words and doing that kind of stuff is intrinsic load, right? Extrinsic load is how the information is presented and how easy it is to get that information and process it. So I need to implement this task. How easy is it for me to find out what I need to implement? If there's a function I need to call, how easy is it for me to find that function and find out what it does? All of that extrinsic information that goes into doing the work. And then germane load is a bit harder to define. It's essentially the effort needed to process all the information that you're getting into schemas in your head and basically acquiring and appropriately storing and using that information. So you can think about it as at the start of a task, you're like, okay, I need to find how we get this information from the database. And so you start searching through the code base. And then how you build up that mental model of how the code fits together. And so in a code base that's poorly designed and code's all over the place and there's duplication all over the spot, germane load is much higher. It takes a lot more effort because there's stuff all over the place. Like, it's hard to work that stuff out. Right? This can be things like lack of documentation can increase germane load as well, because how do I even figure out where the stuff is? And I thought this term meant this thing. If any of you were in Eli's talk before this, talking about language games and how we communicate that stuff, that's a big source of increased germane load. I thought this function or this object in our code base did this, but it turns out it actually does this other thing. Oh, that's changed my mental model of how the code fits together. So hopefully you can kind of see the difference between them. Intrinsic's easy to understand. Extrinsic is other information and how it's done. Germane load is how it's organized and sorted in your brain, right? So I'm going to put this in an example. So let's imagine you have an online store. You're asked to add a suggested purchases section. So somebody's got all this stuff in their cart. Every single site has this. They're like, people who bought this also bought whatever. And usually it's a terrible suggestion. People who bought this washing machine also bought this other washing machine. They didn't. Anyway, but you're asked to implement that recommendations feature, right? So intrinsic load is the actual difficulty of writing that code. Can you, like when you open the right file, how easy it is to open that file, to navigate to the other files that you need, typing the code out itself. It's like the actual meat of doing the physical work without thinking about too much of the implementation, right? As an example in VS Code, which is the editor that I tend to use, getting to a file, Control or Command P, and then start typing the name of the file and hit enter. That gets you to the right file a lot faster than like browsing through the, through the directory tree, right? So that's intrinsic load, doing the work. Extrinsic load is about getting the right information, the correct information. Like, do we have code already that can get some suggested items? Does the database allow us to do a search based on category or, all of that other information that's going to help you get that job done? How easy is it to find that information? How sure are you that that information is the correct information? Are you going to call a function that hasn't actually been implemented, but you didn't know that because it's too hard to find? Does the API that says that it does this actually do that? Which I've hit plenty of times. If you're implementing a feature that reads from a file and parses that and puts that in, maybe there's a recommendations file. Is that file format in the format that you've been told it's in, right? This is all extrinsic load. So if any of that stuff is not effective, like it increases the extrinsic load. Okay. Germane load is the processing of all of that information together in your brain into some kind of mental model, some kind of schema to help you implement and perform that task. So for example, how do I internalize all of that code that I found that implements the different parts that I can use for this recommendations engine? And how do I fit that all together in order to come up with a solution? So you can imagine if there's different parts all over the place, that germane load is quite difficult. The person's previous purchases is stored over here and they didn't store any IDs for the products. They just stored the product names of the things that they bought. That information is going to be really difficult to tie back to the new products and all of that kind of stuff, right? So those are the three types of load that would go into that particular task. And you can hopefully start to see what things would affect the different types of load. I promised I wasn't going to go on rants and delve into this too much, but I just did. So, all right, let's step back. So in terms of these three aspects and how they influence the productivity, and remember we're talking about the developer, like your individual productivity, as well as your team productivity and the productivity of your organization. So not just how well can you perform the tasks that you want to perform, but how well your team can meet their goals and how well the organization can meet their goals. So they found correlations pretty much across the board, as you'd expect, but they're stronger in some aspects than others. So flow state helps your individual goals more than it does the team and more than it does the organization, but that's really just the flow and effects kind of get diluted. So you get your tasks done really well, but there's other aspects to whether your team actually implements their stuff. In general though, if you're enabling a flow state in your organization for your developers, you're going to have good flow and effects to all of these aspects, individual, team, and organization. Feedback loops, this was a little surprising. There are positive correlations to the other, but the vast majority of positive correlations is towards your team's progress. If you have good, effective feedback loops, you have huge positive effects towards your team's productivity. a little bit more than your individual productivity and more than your organisation productivity, which was interesting. There's more detail in this study as well, which I'll give you the URL if you really want to dive into it. And then cognitive load, as you'd imagine, because of the time I spent talking about it, has huge correlations towards increased productivity. So if you can reduce cognitive load, make the job easier to do, both doing the job, finding the information, and then processing that information to be able to perform the task, that has huge benefits towards not just your goals, but your team's goals and productivity, and your organization's productivity. So the lesson here, obviously, is that as much as possible, you want to reduce the load on your team, make the systems and make the environment as efficient and effective as possible in order to ultimately make more money if that's what your organization does, or improve the productivity in general. Right. So I assume at this point you're all sold because there's arrows and they're thick and they do the things. This is all great research and theory, but then how do you actually put this into practice? You know, what can you do with that information? Now, some of you have probably got ideas already about how you can do that, how you can meet these goals. Some of those ideas might be around, well, let's ditch this system, or this process is not adding value. But we're going to talk a little bit more about some simple things that you can do after I have a drink. Okay, let's talk about flow state, because that's kind of the easiest one. In theory, it's the easiest one to do. That Good Day project I spoke about also gives some good ideas for getting into the flow and reducing the interruptions. So let's talk about interruptions first. What can we practically do to reduce interruptions? Now, does anybody here work in an office, an actual office, rather than at home? Okay, these numbers are going up as time goes on. They just dropped very sharply for a while. I work at home. Occasionally I have a 5-year-old and a 6-year-old with me. Those interruptions are interruptions you can't do a lot about. It's very difficult to explain cognitive load to a 6-year-old. But if you work in an office and around other people, there's some things that you can do, and I've done this at previous organisations. Even just like put your headphones on your head. That means don't interrupt me at the moment. We had an organisation where the dev team, it was a decided rule that if you wanted to talk to somebody else, you could go to their desk, you just stand next to it, and if that person is like that, you walk away and you come back in 10 minutes. Like, that's all it took. That doesn't take you out of the flow anywhere near as much as, oh, sorry, I'm in the middle of something, I don't have time right now. What was I doing again? Like, that's a thing that would happen. So that seems really rude, but we had an understanding in our organisation that was okay. But if you're working remotely, the way to do that is to turn your chat stuff off. Do not disturb mode. There's Pomodoro techniques and things like that as well, where you can say, I'm going to do whatever it is, 25 minutes of work and 5 minutes of looking at my emails and stuff. This works better for some organisations and in some cultures than others. I tend to not write code in anger very much anymore. Like, this is my job doing this stuff. But I will still have periods where I need to record a demo for somebody or make sure something works, and I just need focus time for that. So everything else goes off. I'm on a different desktop. I'm in Do Not Disturb. Phone's silent and over there. And I can focus on that for a little bit of time, and then I come back and I check the messages and so on. So those kinds of activities are really handy. But ultimately you need focus time across the board, and I don't know about you, I mentioned that I don't get many meetings during the day because I'm lucky and I live over here. But if you have people adding things into your calendar, sometimes you can't avoid that 3 meetings a day. That means you're just not making any progress. So I want to talk about calendar ops, which is, I just coined that last time I did this talk, actually. Please don't use it. Meetings are inevitable, so you have to have meetings, right? It's just part of the job. You need to talk to people about the work you're doing, right? For some of us, the calendar looks a bit like this. There is no focus time in that. You just cannot do it, right? At most, you're going to get an hour of focus time. Does anybody's calendar look like this, by the way? Yeah, actually that's a lot more people than I thought. That is directly hurting productivity because you cannot focus. You do not have that focus time. And as we've seen, that directly correlates to increased productivity. So one idea, and this isn't always possible, this depends on your, I guess, political power during in the organization. Can you say to your manager, I can't meet at that time, can we do this instead? But just defragging your calendar actually, does defrag even make sense anymore? I think I just aged myself. Defragging was a thing that you used to do with a hard drive where all the files were scattered all over the place, and then you increase efficiency by moving them all into a particular location, and it's faster. A hard drive was a thing. Okay. Sorry, I stole that joke from somebody. Anyway, but basically it means you take, this has the same number of meetings and the same time for those meetings, but it's organized into chunks where you're like, okay, this is meeting time. This is arguably not productive time or not directly towards dev goals, right? But here I have a morning that is focus time, I have an afternoon that's focus time, and I have an entire day that's focus time. I'm still doing all those meetings, it's just I've organized them so I can do the work. If you have enough power to be able to say, oh, I'm not available for these times, and this may literally be blocking your calendar, and I do this a lot. I have a lot of blocks on my calendar to say, you cannot book me for a meeting at this time because I already have one, and that meeting is doing the work that you pay me to do, right? That's a really effective way of getting flow state. Obviously, it's not always possible, but you can usually do some of this. You don't have to decline meetings, just suggest other times and block your calendar, right? Let's talk about cognitive load. I'll come back to the feedback loops because there's less to say about that, weirdly, because I'm a DevOps guy. But we'll talk about cognitive load as it relates to software development specifically and how you can reduce that cognitive load. So one thing that affects all types of cognitive load is context switching. So if you are doing a particular task and then you're asked to drop that and do something else, the switching of context from that piece of work you're doing to a different piece of work is always going to be difficult. But you can ease that a little bit with a few different techniques. This particularly affects extrinsic and intrinsic load, extrinsic and germane load, sorry. The intrinsic stuff of like, where do I find a file and type stuff is usually okay. Like you switch projects and then it's the same thing. But extrinsic load, if you have to continually go to other tools to get information or try and work out why the library that you were just working with isn't there, oh, that's right, I'm in a different part of the code base or I'm a different project or something, that's really hard. Difficulty of finding the information is context switching as well. Where do I go to find the documentation for this new thing that I'm working on? But as well as that, germane load increases a lot as you context switch because your brain is full of the previous thing you were working on, and now you have to effectively ditch the irrelevant parts of that and fill your brain up with mental models of the new stuff you're working on. It's really hard. That's really hard to avoid. So think about the last time you were deep in a solution, like deep in a project. You're holding a lot of information in your head, the structure of the code, how objects relate to each other, the change you just made. And then you realize you need to go and look stuff up because the next thing you need to do with this is to call an API, and I don't have any information about that API. I need to search for it. All of that other information drops out of your head. So when you come back with that information, now you're starting from scratch. Like you've lost the flow, that load has gone up, right? So tools that we use that can help you stay in that flow are extremely useful. It's taken me this long to say the word AI, but I'm going to say it now. Those tools are actually really effective at doing that if you know how to use the tools. But things like IDE tooling, just like autocomplete, and all of those kinds of techniques or all of those kinds of improvements that we've made to our systems massively reduce the load as we do our work. Right? We don't have to keep going out and looking things up. This started with like syntax highlighting. It actually started with monitors, and then syntax highlighting is massively beneficial. And then like the complete, autocomplete stuff. And now you can just ask Copilot or whatever tool you're using, hey, where was this function? And it will tell you. So this kind of keeps you in that flow, and it means that context switching is a lot easier, and it reduces the load on doing that work. I touched on this, but learning extrinsic load, learn your editor. Like learn what it can do. I mentioned the Control P or Command P and then typing in the name. That's, that massively reduces your load because you don't have to go searching for something, right? Autocomplete, IntelliSense, information about what properties an object has. They're right there where you're working. It massively reduces extrinsic load. You don't have to go and search for stuff anymore. It's right there. Things like go to definition or shortcut keys, like what is this symbol? They pull that information for you without you having to jump out of that flow. The actual job of writing the code too, so the editors themselves, as well as the extrinsic load, they hugely reduce the intrinsic load as well. Like my tab key gets 1,000,000 times more use than it used to, 20 years ago, right? This screenshot, I'm using multiple cursors in VS Code. So if I want to change ID to key, that's the editor is saving me a ton of keystrokes, right? So the intrinsic load, the actual task of typing the stuff is much faster. If you are using any kind of editor, like this is VS Code, any kind of editor has all of these tools and shortcuts, it's really beneficial to learn them. If you really like being smug, learn Vim. I hear that's very efficient if you know how to use it. Yeah, we got one person. I mean, if you really want to hurt yourself, like Dvorak keyboard is apparently faster, but there's no way. I'm not capable. Anyway, but you learn the tools because they massively help with load, all types of cognitive load. There's another concept we have inside GitHub called Dev Day Zero, and this is basically how quickly you can write code and ship to production. And the goal is to be able to do that day zero. Like the first time you open that editor, you can change some code and it gets to production, right? So this is being able to kind of reduce the load that you need to do the work that you need to do. So we started doing this internally. So this is also context switching. So can I pick up some new work, be able to implement something, and then throw it away and do the next bit of work? We did this internally, and that ultimately led to a thing we released called code spaces. But it's basically the general idea of disposable environments. So there's really similar things in Python for like virtual environments in Python. If you need Windows machines, DevOps is a very similar thing as well. I was working on this project with all its dependencies and requirements. Now I'm working on a different project. Rather than trying to upgrade the appropriate ones and downgrade the appropriate ones and get the right tooling, you just throw the machine away or stop it and start a new one. Massively reduces context switching and all of that cognitive load associated with it as well. So when we did this at GitHub, by the way, we moved everything, the entire development environment to run in code spaces. So you didn't have to have anything local. It was just all a development environment in the cloud. So it used to take 45 minutes-ish, even after we'd optimized it, to be able to get everything you needed to start writing code. It's less than a minute now. So if I wanted to spin up the GitHub code base, which is about 7 gig or something on disk, I might be getting that wrong. It's gigabytes of stuff on disk. It's less than a minute before I can start typing code and then push, and it'll ultimately get to production. They don't let me do that though, which is probably wise. But having a super quick onboarding time is not just being able to get up to speed with the project, it's also swapping the work you're doing. I was experimenting with this thing, oh wait, there's a priority 1 issue that's come in. Let's just push that aside and do this work. And then it just makes that context switching a lot easier and reduces that cognitive load. All right, the point is that there are solutions for making these development environments disposable, and that's a worthy goal, whether you use code spaces or DevOps or any of the other alternatives too. Being able to switch from one task to another is really handy. Okay, I've held off long enough. This is slide 39. I'm quite proud of myself. My execs would probably not be as happy with me, but I am finally going to mention GitHub Copilot or just AI dev tools. They are, at their core, designed to reduce cognitive load. They are a tool for your editor, basically, or a tool for the software development process that is designed to reduce intrinsic, extrinsic, and germane cognitive load. Right? So the current AI tooling, the stuff that everyone's familiar with, is very much tied to intrinsic and extrinsic code. Cognitive load. So the AI autocomplete stuff where you write a function name and then it interprets what you want from that and implements the function, and you can just hit tab and check that it's all okay. That's intrinsic load. That's far fewer keystrokes. In a lot of cases, it's boilerplate. It saves you just a lot of time typing the letters, right? That's intrinsic. Extrinsic load is assisted by some of the newer features. I say newer because they've still been around a couple of years. But being able to highlight some code and then ask Copilot Chat or whatever the tool is, hey, what does this do? And it explains it in natural language for you. That's really, really handy. Or how would I change this code to do this instead? And it gives you an implementation. Now, obviously, you want to check all of this stuff, but it can get it right an increasingly large amount of the time. And that saves you from the actual work of doing it, so the intrinsic load, but also extrinsic. How do I refactor this to do that, to do this work? I don't have to go and look it up. I don't have to visit the internet and figure out what that means. It's incredibly beneficial for getting that right information to you. Increasingly, you can do things like, hey, is there a function in my code base that does this? And it will be able to tell you because it has indexed the entire code base. It's built connections between the different parts of the application, and it can answer those questions for you. Really, really quick example. This is the, how's this? Zoom. This is the GitHub CLI. So if anybody's used it, it's just GH on the command line. If I'm unfamiliar with this is quite big. All of these folders have stuff, but I can do things like, how is the project? And I'm asking the question, and this used to say, oh, it's a CLI application that uses this and this, but the answers it gives you now are quite in-depth. It's using this workspace thing. It's finding the right references to give you the right information. So finding the right files. And it's saying, here's all the folders and here's what they do. Here's what the code inside them does. I could ask a question like, if I wanted to implement a new command, how would I go about it? And that can find the right information, pull it out and give you that kind of information as well. So that's really handy. It's really beneficial for getting that right information to you, so extrinsic load. We've started, and this is things like agent mode in Copilot. We've started with understanding and processing that information, so a bit more of the domain load, where you can say, I have this feature that I want to implement. Can you help me implement it? And it will find the information, it'll build the schema and the models of how it fits together and say, well, to do this, you'll need to change these parts of the code over here because this is how they work together. And this test is no longer going to work anymore. Let's do this to that test, or let's increase these, let's include these tests and things like that. Agent mode, depending on your level of comfort, can offload a lot of that as well. So rather than just telling you what to do, it just does it. And then you can review it and see whether it's good enough. You can ask for updates and changes and so on. I'm not here to sell stuff, so I'm just going to move on. But imagine that scenario with the online store and the suggested purchases section that we had before. So all of that complexity and cognitive load that we were talking about. In this ideal scenario with AI tooling, if you can just describe that scenario to this tool and it can retrieve all of the moving pieces that need to change with that and pull them to the fore and say, well, here's what you need to change here, 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 and here. Here are all the changes that I've made. Do you want me to run the test again? And you can say, yeah, do that. And it runs the test, it finds one that fails, it looks at why it fails, and it says, oh, okay, that's because we introduced this thing, let's fix the test, run it again, that's fine, this looks great, review it, what do you think? That's kind of the goal. This is reducing intrinsic load because you're not typing the stuff out anymore. You're reducing extrinsic load because it's finding the bits of information you need to solve that task, whether they're in the code base or on the internet, or with third-party tools using agents and things like that, with model context protocol, all sorts of stuff like that. So pulling the right information, and then the actual doing of the work is putting all that stuff together, working out what needs to change and how that model works. So the goal here is really to reduce that cognitive load as much as possible. So this is here, experiment with it. It's still early days, so always look at the code that's being created. Don't just trust it and go. But yeah, that's really handy. And just to close this out, it's not quite as sexy as AI or germane cognitive load with work design theory, but feedback loops, if you can shorten those feedback loops and make sure that they give you a lot of signal to noise, like it's only the relevant stuff, then that can massively increase your productivity. Things like CI/CD and efficient patterns like that, automated testing, and even the tools internally that give you quick feedback, like the squiggles underneath your code to say this is not working, incredibly useful for improving your productivity. Right. So here's the summary. Better developer experience, so the environments that are efficient for doing the work you want to do, gives happier developers. That's just a fact. If you're not fighting against the systems, you are going to be happier with your day. That Good Day project kind of showed that quantitatively. When you have better systems, you feel better about your job. And it also showed that that leads to better productivity. So your company is meeting their goals more if the developers are happier, if the systems are better. Right. So this is all in those studies. The Good Day project, I want to leave you just with one more thing from that, one suggestion, is that there's actually a really positive correlation between having a good day and spending 5 minutes at the end of the day to reflect on what you did that day. So just before you close the lid of your laptop or turn off your computer, you say, what did I actually do today? And write it down, or just think about it even. Because often we finish the day with something frustrating and then walk away thinking, this was a terrible day. Spending 5 minutes at the end of the day just to look at what you'd done and whether it was useful actually correlates really positively to your happiness as a developer, and then ongoing your productivity as an organization. This is a URL with a bunch of links in a GitHub gist that point us to that research and a bunch of other stuff like that if you wanted to look them up. I think I'm pretty much right against time, am I? 5 minutes, oh great, that's like 12 questions. Still seeing some cameras out, so I will leave that for a second. But thank you. If anybody has a question, you can do that. Yes?
Is the Unicorn Project book worth reading?
Is the Unicorn Project book worth reading? Yes. Yeah, it's probably the second book around that topic that I've read cover to cover. The first one was the Phoenix Project. It is. It's kind of focused around the ideal set of principles. So there's like 5 ideals for software development, rather than the Phoenix Project was a bit more, team stuff. This is kind of, much more towards the DevX kind of developer experience. Yeah, I'd recommend it. It's good. It's very good.
Which one to read first?
Phoenix Project first, yeah. I'd read the Phoenix Project first and then Unicorn Project. But either one of them can stand on their own. So if you only want to read one book, just read the one that's most relevant, I think. Sorry, there's a question back there first.
Was there any benefit to front-loading versus back-loading meetings? Getting the meetings over and done with, but you start to spend all day thinking about meetings?
That's a great question. The question was there any benefit to front-loading, like so having the meetings first up to get them over and done with, or doing the work first and then having your meetings? The short answer is I don't know. It might be in that research. It was a while ago though. I was going to say I could probably ping Arini, but that would be rude 4 years after the study. I don't know is the short answer. I suspect it probably depends on the person. I can see pros and cons to both. I don't want to start my day with meetings because then I just feel bad. But then I don't want to finish my day with meetings because then I'll feel bad. So just no meetings is the solution. Yeah. Sorry, that's a question.
You mentioned name of the tools that say that it doesn't work internally, that this improves the productivity. Can you mention the name again?
Oh, the tools that measure productivity internally?
No, the
Sorry.
tool you mentioned, internally it's set to developer that this doesn't work before we give it to the tester. Did you mention something?
I don't know. Hang on. So a tool that we were using, yeah, maybe we can talk after. Was it GitHub Codespaces? No.
Feel like we do stuff internally, like we have an unfair advantage to develop stuff and then we can sell it.
Oh, yes, sorry. Yeah, the tooling that we use internally that is GitHub itself. So we do developer tooling, yeah. I can't remember what we're calling it these days. Hopefully the recording stopped. Yeah, but it's the whole platform of like issue management and the code base and GitHub Copilot, that, you know, all that stuff we work on internally. And so if it improves our lives, it improves our customers' lives and things like that. But we chat afterwards if yeah. Okay, cool. Yes?
Do you continue to monitor happiness over time, or is it just a one-off project?
Question is, do we continue to monitor happiness over time, or is it once off? I think the research specifically itself was that once off thing. I don't know, other teams might, but I don't think there's any more like a global, this is what the metrics are at GitHub now. It's a worthwhile exercise.
So you could like evaluate if something's actually...
Yeah, that's right. Yeah, comment was you can evaluate if something's actually beneficial or not. Yeah, I think the goal then was to kind of work out what things we should probably focus on in terms of productivity. But yeah, I will ping Arini and say, hey, when's V2 of this one coming out? Yeah, cool. Awesome. Thank you so much, everyone. Hope you have a great rest of your day.